Okay. So let's start with the second and the last session.
The second and the last session.
The second and the last session. Yeah, maybe let me start with a short introduction. My name is Christian Kurz from Nordic Semiconductor. I'm a field application engineer working at Nordic since April 2020. So my first task was basically, I was told, Chris, take a look into NF Connect SDK and dig a little bit deeper. Maybe that triggers something for me. Before I start with the presentation, I'm interested to learn more about the audience, the people who are in. So I'm first of all interested in, are you working with Zephyr? Just show up. You are, yeah, a lot of people. I have some basic stuff here also, so we'll do the basic stuff, and I hope that the experienced people can agree in what I'm talking about. And yeah, are people in the room who work with the NF Connect SDK from Nordic? Yeah, it's not really a big difference, I would say. So the NF Connect SDK, for those people who are not aware that the NF Connect SDK, this is the Nordic SDK which we are using. And there was a decision 2016 from Nordic side that we will use Zephyr as our base for our SDK in future. And this was really done. We introduced some time ago, years ago, the NF Connect SDK. And if you take a closer look to the NF Connect SDK, you will see that the base is really Zephyr. So we make a fork of the Zephyr repository. We add it to our GitHub page. And when you install the NF Connect SDK, the core, the heart is really Zephyr. And all the toolchain which we are using is Zephyr. So because of that, it's quite simple for me to talk about our product, our SDK, because it's basically the same like Zephyr. And here for the day, for today's session, the focus is basically on Zephyr. So everything I'm talking about is basically true for Zephyr as well as for the NF Connect SDK. So that's the nice thing. Okay, Zephyr's new hardware model. Who has participated in the last Zephyr meetup here at Concentrics? Also some people. So you heard already from my colleague the presentation about the new hardware model. There's a recording on YouTube. I have in the slide deck at the end the link to this. I guess we will share the slides later on, right? Then you will have the possibility to take a look on that.
One thing, could you also try a screencast if that's easy for you? Because we are not able to record this because we have technical problems.
It's fine.
Okay.
Okay, great. Sorry.
Okay. Hardware model. Yeah, my colleague talked about that, and I thought, okay, maybe it's a good idea to do it again here, especially since some people from Concentrics asked for that. And the reason is quite simple, because the new hardware model is just in the progress of being released. And in the presentation, you will see more about that. So I have some old, new comparison, and yeah. What I'm also wanted to do is, I'm a practical guy. I want to use it. So I'm not a software R&D guy who knows all the background, why this was triggered and why it was introduced. If you're interested in that, go to YouTube, take a look on the previous session that was given here. So there you see really the R&D, software R&D side in the explanation what's about the new hardware model. I do it more in a practical way, and I'm thinking more in the way, what does it mean if I want to work with it? And maybe the first slide here, that's more for the people who really knew in Zephyr. So this slide here basically describes how a Zephyr project looks like. And what you basically also see here is what Nordic is basically doing. So we have our GitHub page, NF Connect page, where all the repositories that are included in the SDK are stored. And if you install the NF Connect SDK, you basically move the complete code base on your computer. The complete code base basically means the Zephyr, the complete Zephyr repository, MCU repository, which is also used by Zephyr. But what is specific in the NF Connect SDK is really Nordic Semiconductor specific parts. So there are a lot of repositories where the open source community are working on, and also Nordic people are working on. But we have also some software parts where only Nordic software engineers are contributing to it. And this is what we include in our SDK. So the purpose is basically there. This is Nordic chip-specific software which we include there, where the big open source community don't really have a big advantage. One example is NRF-XLib. These are basically our peripheral drivers, which we provide here. And what Zephyr is basically doing is they are heavily reusing this stuff. So if we think about the peripheral drivers, the hardware drivers, which are included in Zephyr, and if you dig into it, you will see that these basically use some parts of the peripheral drivers which we offer, and which are also part of the Zephyr repository. Because of that, it is also possible to use our parts if you only have a Zephyr, pure Zephyr installation. Okay, let's think a little bit about how to create your application. If you download the code base, you can't reuse the complete code base in a resource-constrained microcontroller. So you want to put some parts out of the code base and use it for your application, for your project. And kconfig is here the keyword. With the kconfig, you basically have the possibility to add some software parts, some software modules to your application by setting the appropriate kconfig symbol. If you have set that, you will see that you will get access to further config symbols. And these further config symbols basically allows you to configure the software module you have just added to your application. So in this example, we add the Bluetooth stack, and then there are a lot of config symbols which allows you to do the configuration of the Bluetooth stack. For your own application, for sure, you will also write your own code. And that basically builds the C code which you use then. There's a nice, I'm not sure where I've read it. So either it was Reddit or it was Stack Overflow. There was one comment from one guy who was talking about Zephyr, and he was basically stating doing a Zephyr project is basically 80% configuration, this part here, and 20% writing own code. And if you start with it, I guess those experienced people here in the room may agree to that, because Zephyr is coming with such a big amount of code libraries, of device drivers, of sensor libraries, so that you can reuse a lot of stuff. Okay, that would already work. But maybe you want to run the application, the source code, on different boards, where maybe different GPIOs for the LEDs are used. If you would do this, you would have to modify your source code. That's ugly. That's not nice. Especially if you think about the code base here, the device drivers which are provided. So if you would have to touch this again and again to modify it for the different boards, for the different projects you're doing, that would be crazy. And because of that, the decision basically was done that also device tree is used here in Zephyr. And device tree, this is basically using a device tree source file, an own file, where with a specific language, the hardware is described. So here you basically define which GPIO is used for LED 0, for example. In the source code, you basically have to access this DTS file and read out the settings. And by this, by just changing the DTS file, you can run the same code without any changes on one board or the other board. And that's the idea basically here. Kconfig device tree. What does this have to do with hardware model? So hardware model, okay, yeah, here device trees, that makes sense. Maybe also the configuration, because if you have a board, for one specific board, you may say that certain features should by default be activated. Then it would be nice to define a board with the hardware description language, but also include some software parts. And this is basically the board definition, which is done. And if you follow the GIF here, you will see in the Zephyr folder, in the Zephyr installation, there's a boards folder. And in the boards folder, you find more than 540 different boards which are supported. Boards which are coming from semiconductor companies, from module makers, some makers, and I called it products, like the BBC microbit. So here we basically have examples how a board definition file could look like. And the nice thing is, if you do your own product, you can do your own board definition. You don't have to reuse existing ones and modify it. You can really do your own board. And now we are already coming to the new hardware model. So, and on the following slides, I try to do the split to show you, okay, that's the old style, that's the new style.
Vendor and architecture.
That's just a minor thing, but there is much, much more. So important to understand is the current version, the current official release of Zephyr is 3.6, right? 3.7 does not yet exist. This is still the main branch. So I basically took this from the main branch description documentation. And as you recognize, yes, one big change here is basically that the folder structure was updated. So that's basically my installation path, or where I installed the Zephyr project. In the Zephyr project, you always find the Zephyr folder with the complete Zephyr repository. In the boards, there will be a Nordic. And in the past, they did it in a different way. They basically mentioned architecture. Here, in this case, it was ARM. And then you had a huge list where you really had to scroll for days through it to find the appropriate boards. Now this is getting a little bit better. And this already shows you why a new hardware model was needed. Because the progress of the project itself, it came to the situation, it came to the point where some logical changes, let's call it this way, had to be done. From one side to handle the big list of boards which are supported here, but on the other side also other things. Other things like, and I'm sorry that this is really Nordic oriented, so I always picked out the Nordic dev kits here. So if you take a look on the old style, we had these strange boards here, NF52DK. So we have only one NF52DK. But in the board definition, we did a separation of different device types. Why was this done? It's quite simple. So as a semiconductor manufacturer, we do not really want to have for each single device an own dev kit. We use master devices to emulate smaller devices. And by this, we can live with one DK, the NF52 DK, and use this board to work on the device which is on the board. Or if we reduce the functionality, we can also use spins, smaller memory, less peripheral modules, and still work with the same DK. And the new style, here you basically see again the update, which makes more sense. There is just one NF52 DK, and all the definitions are basically done in there. And this was basically another trigger why a new hardware model was done. Because handling of a single board, doing in a better way than creating several boards to cover one development kit. Let's dig a little bit into it. So I took a look in the NF52 DK, the big device. So there we had some definitions. The important ones. Oh, I should not step on the cable. The important ones are basically the device tree source file. So here we have the device tree file that defines the hardware on our dev kit, where the LEDs are connected, where the buttons are connected, where an SPI interface is connected, and there may be a sensor. And that's basically included here. Dev config, that's the second thing I was talking about, kconfig. That if I define a board, it may also make sense to add some software modules by default, because if you work with this board, you basically need it. And that's included here. And the nice thing is, I should complete this. If we take a look in the other definitions, you basically see, yes, the second board and the third board, this is basically more or less the same. The only variation which we have here is really the device tree file, because different peripherals are existing in the microcontroller. The start address, the size of the flash is different, the size of the RAM is different, and that's basically covered in the device tree file. Dev config, most probably that's more or less the same, because the dev kit uses more or less the same definition. Let's take a look in a new style. And here we just have one dev kit. And in this one dev kit, all the boards, all the variants are basically defined. How can I now use this? And there's one new file, the board XAML file. And in the board XAML file, you can do definitions about your dev kit. And in this case, basically, the device, the chip variants are defined here. There's a second file, new file, where basically the configuration is included for this file, so that the peripheral set is included in the project. And you can access the according peripheral modules which exist in the smaller devices or the bigger devices. Good. But there's more. Board revisions. Okay, usually a dev kit, if we create it, maybe there's a small chance that it will change over time and that some updates are needed. So it would be cool to cover also revisions, board revisions. And this is exactly done here with the 9160 DK. Here you basically see that suddenly we are working with revision files.
already possible, I think. So.
That was already possible, yeah. That's right. That's right. So the wheel was not invented again here. So useful stuff was reused in a more logical way. So later on, I have some examples how to use it, how to do a build and select the board. But that was important.
It actually wasn't really possible in the same way because before it was all just boards,
Yeah.
right? And now you have a semantical difference really between versions
Yeah.
on the one hand and revisions on the other hand, and you can actually do the cross product of the two, right?
Okay.
And that's also why the board YAML changed. So you really get a semantic difference now. It's not new boards, but you actually have the system understands versions and revisions, and that also displays in the West command. So it's much easier to use from a user's perspective as well. Because otherwise you had those long board names, right? Which are actually just the cross product of all the different combinations.
Yeah. But I think with the revisions, it was possible with add
Yeah.
revision.
I have an example later on. So let's wait for the example, then we can take a look. Board revision, TrustZone support. TrustZone support is also cool. And here we basically have the TrustZone basically means you have one CPU, a core which supports TrustZone, and TrustZone is basically used to allow the CPU to get in a secure and a non-secure domain access to certain peripherals or to certain address ranges.
Which is actually the naming convention is quite unusual because you have to name your files with NS for a non-secure application if you want to create a secure application which using TFM, which is quite a little bit hard to understand.
Yeah. So for the 9160, we do it, and that's the old style. We do it in a way that we add NS, and we add basically not NS if the secure domain is done. But that's also not new. So this already exists, and that's basically also reused. And if you take a look here, so there's some section where the non-secure domain definitions are done and where the secure domain definitions are done. What's more important and what's more triggering the new hardware model is the last point. Multiple SoCs on a board, or even if we talk about multi-core SoC solutions. So multi-core on Nordic side, we had the NRF5340 with 2 cores inside. There was an application core and network core. And the application core itself also supports TrustZone. So basically you have to think about 3 projects for one single IC and handle this. But multiple SoCs on a board, that was not really covered in a good way so far. And that's also now possible. So we basically did this already, and the old style, which we basically did is we used NRF, the development kit name. And on the development kit, we have also a 52 device, which can be used for BLE. We can also use it as a USB bridge in our example here. And that was also included here. So different things which basically pushed for doing the new hardware model. New hardware model, if we want now to define a certain board, we are basically using this way here. So I have a better example on the next slide. So we use the board name, and then the board revision is optional. So you can mention the board revision, or if a board is defined in the board YAML file, there are the different revisions named, and they usually also define a default revision. So if you don't take care about that, the default revision will be taken, and most probably this is the latest version, I would say. SOC, the board qualifiers, that's then again important. You have to use this, especially the SoC. CPU cluster makes only sense if you have a dual core, a multi-core system. Then you define, okay, this is for the application CPU, this is for the network CPU. And the variant that would basically be, is this a non-secure or secure domain? And the way how it is used now is in the same way like before. If no variant is mentioned here, CPU app basically would use the secure domain if TrustZone is available on this part. And if NS is used, then a non-secure domain is used. So I took this from the Zephyr documentation. I looked for the board. It's a module coming from that. And here you basically see the definitions of this. So not everything is defined here. There's no revision definition. So because of that, yes, this is just an example where a complete name was used, but this does not really exist. I looked for a different one, and sorry that I took again a Nordic part. NF 9160 DK. We define the revision. The revisions are defined here. So here you also see that the default is defined. So with this NF Connect SDK version, I could also not use the part here, and then automatically the latest revision would be used. If I have an older board, then it makes a lot of sense to use the revision. For sure, we have to specify the SoC. And then it really depends on do we want to use the non-secure domain or the secure domain? If we want to use the secure domain, remove these characters. That's the secure domain. And if we add /ns, we will place the application, the project into the non-secure domain. Yeah, that's the example with the revision. So if we leave the revision out in the board name, then automatically the default revision will be used and the project will be compiled for this. I played around with that already. So if you install the official release, you will not see this yet. You will still work with the old version. If you have downloaded Zephyr main branch, you see it already. And this is what I have done here. If you're working with the NF Connect SDK, NF Connect SDK version 2.6.0 is using the old style. There will be a new release in June, NF Connect SDK version 2.7.0, and 2.7.0 will have the new hardware model included. And keep in mind, it will be a hard cut. So there will not be an option in the next releases to use the old style, so you have to use the new style.
One question, are you now releasing on top of the 3.0 branch, the new one, or is it really backported to the 2.0 branch of the main line, I mean?
The way we do the releases is we do not really use official Zephyr releases.
I know.
We use branches, we make a fork, we store it on our github.com/nfconnect webpage. There you find a Zephyr, SDK Zephyr folder, and that's the forks from Zephyr. And what we basically do is cherry picking. So if we see, yeah, we are early in the main branch, there's already stuff. Good thing, our people are working also for Zephyr, so they push the stuff in. And as soon as we get a new SDK from our side, we can ensure that certain stuff is included in Zephyr, and we do the cherry picking and offer it already in our NF Connect SDK.
But it's based on the free.
Sorry.
It's based on free. On the free.
Okay, so you're forking off the 3.6 or 3.7 now in the future. That's great. So you're very close. I think it's
we try always, if we do a new release, we try always to use the latest version.
Perfect.
Maybe even using some parts which are in the Zephyr main branch.
Yeah.
So the cherry picking to have features early available. And this will exactly happen with the new hardware model.
Do you know why you're calling it still 2. something? Because it would be nice if it would just follow the...
Yeah, that's a good question. I haven't asked my colleagues, I have to say.
Okay.
But so we went to version 2 when Zephyr went to version 3. So at least the major release, we were synchronized. I'm not sure why the first time this was not done. It would make sense, but yeah, it is like it is. And maybe it's not too bad because the NF Connect SDK and the Zephyr version may not be the same one, even if they would call it the same way. So having
That is confusing because you wouldn't think that it's the same.
yeah, right.
Maybe you should go to 6 or 7 or something.
Now, I think as soon as Zephyr is doing a new major release, I would assume that also Nordic is doing this, because then a bigger step will be done regarding how the project handling is, blah, 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 and then it would make sense.
Interesting that this board or hardware model change is not considered a major.
Yeah. So I'm not sure why they are pushing so hard for that. Most probably 3.7 will be an LTS version, and they want to have it in there.
Okay.
That's just a guess. Okay, let's continue here. So the nice thing is, if you're in doubt, what I have done here is I've basically done a build of a project, and as a board, I have only given the NF 9160 DK. And then if the build is done, the pristine basically means erase the old build folder. That should be done with the new hardware model because certain things are stored in the build folder. And if you change the board name, you may see some trouble. So doing a pristine makes always sense. And if you do this, you basically get the information, the valid board targets are blah, blah, blah. And this is basically the stuff I should use here.
Sorry.
Yeah.
Is this still true if the board only has one SoC? Or not? For example, you have a board that only uses one SoC. Why would I have to put the SoC in?
The example is basically this one here. I would have here one dev kit, but I could use this dev kit for different SoCs.
I understood that explanation. I was talking more in the perspective of someone that is using it for development, and not in the vendor side of it. I'm talking, for example.
But also for development side, you should think about the device which is on it. And here, this example is quite good because here you also see that on this board, on the 9160 DK, we have two SoCs on the board. An NF52, a Bluetooth chip, and we have the cellular IoT chip on the board. And the cellular IoT chip, basically the CPU supports TrustZone, and that's the reason why the secure non-secure selection could be done here.
So you actually had to enter something when you do the build. So it's build now.
Yeah, right.
But it didn't find out probably how it works if you only have one selection, because I think that's the question, right?
Yeah.
If you only have one selection, do you have to enter the same data as well? Do you have to confirm something while building, or then just running through?
It's basically the example here. No.
If there is nothing to select, would you have to do it interactively? I mean, it's probably less.
So if you do the build, for sure you have to define a board. That's something which you don't really come around. I'm not sure if there's a... So regarding our dev kits, we always have to specify an SoC because most of the dev kits also define emulated devices. But that's a good question. It's possible that there is a way that only the DK name would be good enough. If a certain separation has not to be done. But I'm not 100% sure here. So I have not seen this yet. What I have seen is this was always the simplest board that I could select. So defining the...
If it doesn't exist, you can just upstream it because it's really a simple change. You exchange
Yeah.
and you just make a contribution.
Defining the board name Most probably SoC is really a mandatory thing. Because if you take a look in Zephyr, Zephyr does board definitions, but Zephyr is also doing SoC definitions. And there's this nice graphic which defines, okay, you go from architecture over SoCs to the boards. So most probably you will not come around defining a certain CPU here.
It would be good, for example, to have kind of a default, just like when you have the variants, for example.
Yeah.
I think it's probably a good idea to define the SoC anyways. Just thinking about obsolescence.
Just in case in the future you change it.
Chip manufacturers will stop making the chip. They will.
But that could be also the version of the word, the revision of the word. I don't know.
I think it's really if you have only one sub defined in your, because you can read it, right? It's just metadata, and that's exactly the change now. There is a semantic difference now. You can see it, that there's only one sub supported on the board, and then of course it should be selected by default. If there's nothing to select, I mean, the user shouldn't be disturbed.
I think I'm 90% sure that it will take the default one.
If it does, really, it's a small change. So let's do it. It's open source.
But all this stuff is really new, I have to say. And if you're interested, this stuff is discussed on Zephyr. Look for the new hardware model version 2. Then you find the discussions on Zephyr. There you can really dig into it. Yeah.
Having to write a very long email.
Yeah, right.
Forward.
Okay, let's continue, not to lose too much time. So TrustZone examples how TrustZone is used. So I've used here the 5340 DK. And I have 3 definitions. So first of all, the secure domain on the application core, the non-secure domain on the application core. And since this is a dual core, we have also a network core, which does not support TrustZone. Because of that, there is no NS version for that. And the new definition would basically look like this. And finally, the revision. So yes, revision also existed in the old version. As expected, it was basically added at the end because that was basically a file name that has to be there. And in the new setup, you basically define the board, and then you can add the revision number followed by the board target, whatever by the definitions of the definition of the SoC. And that's more or less what I have prepared for today. The last slide is basically just showing some references. I talked about the Zephyr Meetup in January, where my colleague was already talking about hardware model. So it's not completely there. If you work with Zephyr main branch, you will already see it. Visual Studio Code, if you work with the Nordic extensions, you will see that at the moment this is not yet covered. Certain things are already prepared for that. And the rest, I would assume, will come in June when the next release is done and where we really switch to the new solution. There was also a tech talk about the new hardware model. So that's recording, and I have put here also the YouTube link. And the rest is more or less documentation on Zephyr. So, and I pointed to 2 chapters. First of all, the custom boards device tree and SoC definition chapter, which covers the new hardware model, if you take a look on the main branch version of the Zephyr documentation. Or there's also a porting chapter where you find a transition to the current hardware model. And this is basically describing how to move to the new hardware model. What does it mean regarding board definition? If you work with the dev kits which are coming with Zephyr, you're in a good shape because these will be migrated. So the change will had be done. And as soon as the new SDK versions will be released, these predefined boards are coming in the right way. It's critical if you have defined own boards, if you have custom boards, because then you have to do the migration. And as I mentioned, new hardware model is a hard cut. So in the next version, Zephyr main branch or Zephyr version 3.7, or in the NF Connect SDK 2.7, which will be released in June, you will see the hard cut. And then your own board will not work any longer. So you will see errors. And the nice thing is, transitions, there's also a Python script described, which comes with Zephyr, which helps you to do the migration to the new solution.
But in the best case, I would only add this YAML file and then I'd be done, or?
Not really, not really. So I would use the migration tool. It's a little bit more. So I have not really covered everything. So I did it on a high level, I have to say. But I would use the migration tool if you have a single core solution, board definition. It's super easy. Then it should work quite well. For sure, you have to test it. If this is a multi-core board which you have defined, which most probably will not be the case, but then the tool, the migration tool, the Python tool may not be sufficient, and you would have to do some manual stuff. But I would not assume this is yet the case. So what I'm seeing is multi-core solutions are coming in future. So Nordic is working on that. I guess you have seen this on our webpage, what will come there. And if we talk about not any longer a dual core, but really a multi-core solution, then this stuff is really getting more important.